Okay, this presentation is about chloroform, which is a compound that is widely spread in the environment, and ways in which we can reduce its presence in the environment. Start out with, what is chloroform? It is a very simple halogenated organic compound. Trichloromethane is its IUPAC name, and it is 3 chlorines bonded to 1 carbon with a hydrogen on the other end of it. It is a polar tetrahedral molecule. It was historically used as an anesthetic, which is why you've probably heard of it. Well, we're not in an audience situation anymore, so yeah, you've definitely heard of it because you've probably used it in biology. I will address my audience directly, right? Alright, so the physician, Robert M. Glover, who discovered its anesthetic properties and began using it on patients and surgeries, actually died at a pretty young age, in his early 40s, after suffering for quite a bit of time with addiction to chloroform. So it's no joke, it's like a really serious and toxic material. It was discovered by Jean-Baptiste Dumas in 1834. I'm saying it like that because he's the first researcher who correctly identified its structure, and he also gave it its name due to its similarity in structure to formic acid. So it's like pretty toxic. Primarily on the liver and the kidneys as far as its systemic toxicity, but it's also a local irritant, so whatever route of exposure, if you're breathing it in, your throat and lungs will be irritated. If you're dermal exposure, the spot on your skin gets, the oils are removed and then the spot becomes quite irritated. It's also capable of altering the development of neurons. So it's, not good to have it be around at any stage in your life. So it's like pretty widespread as well. Anywhere where there's municipal supplies of water that are treated with chlorine to disinfect or to prevent living organisms from being in the water and making you sick, that chlorine interacts with any organics in that water to produce a variety of halogenated organic compounds, the most common of which is chloroform. People in a public swimming pool were tested for how much chloroform they had in their blood, and in some, the range was anywhere from 0.8 to 25.1 nanomoles per liter. And I did the math on that. That's 9.55 times 10 to the minus 8th grams to 3.00 times 10 to the minus 6th grams per liter of blood. That's dermal and inhalational exposure at a swimming pool, and in showering, that's another way you can be exposed to chloroform. Washing the dishes, stuff like that. Anytime where you're in an enclosed environment with hot water, where the chloroform is vaporizing and you get an inhalational exposure. It's extremely small amounts, but it's more than nothing, and I think it shouldn't just be ignored. Chloroform, interestingly, occurs naturally. Like I said already, it's sort of like an end product of the interaction between chlorine and carbon. So it's kind of hard to have those elements around and not end up having chloroform. There was a study with where they checked groundwater and forest soils for a variety of compounds, and they found that there was chloroform in the absence of typically associated organic pollutants. And then they did studies on the isotope ratio, and they found that the chloroform found in forest soils and in groundwater has a totally different carbon isotope ratio to the chloroform that's industrially produced. So that indicates, that it's of natural origin rather than anthropogenic. Also, there's algae that produce a variety of halogenated organic compounds, including chloroform, and so it's coming at us from all angles. So you'd think that such a simple compound would be pretty easy to either do some sort of chemical reaction with, or some sort of like absorption type stuff to remove it from the environment. But unfortunately, a lot of chemically induced, like hydrogenation, for example, is a chemical process that can replace the chlorines in chloroform with hydrogens. But the chemically induced form of doing this doesn't typically go to completion. So you end up, because chloromethane is a gas at the temperatures and pressures found here on the surface of Earth, it tends to escape reaction vessels unless pretty stringent controls are applied. And it's just a huge expenditure of energy. It's difficult, and then the issue with chloromethane is that is more toxic than trichloromethane. So it's kind of like all or nothing. If you're going to alter chloroform chemically in order to remove it from the environment, you're going to need to make sure that what you're doing is completely effective. So, quite helpfully, there have been some species of bacteria which can at least reduce chloroform by adding electrons and the corresponding protons that go with them to produce dichloromethane, which is a lot less toxic. Not exactly drinking water status, but it's like a lot less toxic than chloroform or monochloromethane. So these species, the Dehalobacter species, use chloroform as the terminal electron acceptor in anaerobic respiration, which basically means they're able to generate cellular energy by breaking down chloroform. But they only do a single reduction step, so they end up accumulating dichloromethane, which is toxic to the organism and eventually kills it. However, there are some Desulfitobacter species which use a different degradative process to hydrogenate trichloromethane all the way through dichloromethane, chloromethane to methane, which it is a greenhouse gas, but it's a lot less toxic than any of those chlorinated compounds that is being removed. And then the chlorine from those from trichloromethane molecules winds up in a reduced state, either as hydrogen chloride or as a chloride salt. And there's a bioreactors. There's a study where they loaded bioreactors with different species of bacteria that process chloroform and 1,2-trichloroethane and 1,2-dichloroethane, a variety of other compounds. They loaded these bioreactors with different concentrations of the different organic pollutants and were able to find out what the most effective concentration and species mixture for removing chloroform is. And in a separate study, other researchers produced these mixed species systems and took them to landfills and did studies where they studied how much of the organic pollutants were removed using these species, and they were able to find a way of bringing the chloroform concentration in the soil down to like less than 1% of what it was before. So that's quite substantial, you know, very good. So yeah, the chloroform is a natural and anthropogenic compound, just toxic, useful for chemists and biologists, and pretty much we're developing technology now to be able to manage the levels of chloroform in the environment. There's the presentation.